Hello, we are going to continue our revision of last year's algebra and we are going to be focusing on equations. So there are several different types of equations. We might be bringing in things that we would have done for multiplying out brackets or adding up like terms, but we also have some other rules that we need to keep in mind. Now the key thing for an equation is that we are always trying to find a value of x. So we start out with this messy looking situation and we always want to bring it around to x is equal to some number. So the x is what we are trying to isolate, and then we want to have numbers on the other side. So currently we have numbers multiplied by the x and numbers added around the x, and we don't want either of those things. We want x by itself is equal to a number. That's our aim, and we have to remember the rules of working with equations in order to achieve that aim. Now, the key thing to remember, or the key tool that you can use to remember what can happen with an equation, is a balance. So if we have a weighing scales, traditional weighing scales, we have our two plates, and if our weighing scales are balanced, to keep them balanced, we'd have to take the same amount from both sides. So if we had a balanced weighing scales, and we said we had 10 kilograms on the left-hand side and 10 kilograms on the right-hand side, if we took away 5 kilograms from the left-hand side to keep things balanced, we'd have to take away 5 kilograms on the right-hand side. And an equation works the same way, because this line here is a claim. We're saying that all of this stuff is exactly the same, is equal to all of this stuff. So anything we do has to keep them equal to each other. So if we say want to get rid of the plus 2 next to my 3x, which is usually what we're going to do, we're going to do our addition and subtraction first, unlike BIMDAS, where we would be simplifying on either side of the equation. When we're simplifying the equation itself, we do addition and subtraction first. So we want to get rid of this plus 2, so we'd have to minus 2 from the left-hand side of my equal sign. There's a big imaginary line going down here, and we have the left-hand side and the right-hand side, and we have to keep both sides balanced. So if I subtract 2 from this left-hand side to keep the balance, now that I've subtracted 2 from the left, I'd have to subtract 2 from the right. So I have to subtract 2 from the right-hand side so that I keep these two things equal, so that I keep my equation balanced. So what happens now? I have 3x plus 2 minus 2. Well, plus 2 minus 2 is 0. That's why I took away minus 2, why I took away 2, so that now on the left-hand side, I just have stuff involving x. So by taking away 2 from the left-hand side, I got rid of the numbers. Now this is simpler. This is closer to where I want to be. I have no numbers by themselves on the left-hand side. And now I have minus 4 minus 2 is minus 6. So I've made progress now. I now only have numbers on the right-hand side, and I have stuff involving x on the left-hand side. But I want to have 1x, and at the moment I have 3x. So how am I going to get x by itself? Well, I know that any number divided by itself, say if I had 10 and I divided it by 10, I'd end up with 1. Or if I had minus 4 divided by minus 4, it would be equal to 1. So if I want to end up with 1x and I have 3x, something I could do would be divide by 3, divide by the coefficient, the number in front of my x. And 3 divided by 3 will give me 1. But again, if I've divided the left-hand side by 3, what must I do to the right-hand side? I must divide it by 3 as well. So 3 divided by 3, or 3x divided by 3, 3 divided by 3 is 1. So I have 1x, and now I have minus 6 divided by plus 3 is going to give me minus 2. So minus divided by plus is going to give me minus. 6 divided by 3 is going to give me 2. So my final answer is 1x would be equal to minus 2. Now let's follow this on down. Again, here I have x's and numbers on both sides, but I know that I eventually want to end up with x is equal to numbers. So I want to get rid of this 7x over here. I want to just have x's on the left hand side, and I want to just have numbers on the right hand side. So I need to get rid of this 7x, or I could also get rid of that plus 2 first as well. It wouldn't matter which one I went with first. So I want to subtract 7x from the right hand side. But then to keep things balanced, I have to go to the other side of my equal sign. Again, you can put your dashed line down your page if you want, but it's on the other side of the equal sign, in this case the left hand side of the equal sign, I need to subtract 7x as well, and I'm going to subtract it away from the like term. So here I subtracted plus 2, I subtracted 2 away from plus 2 and 2 away from minus 4, and now I'm going to subtract 7x away from 7x and 7x away from 5x. I'm not going to try and subtract 7x away from plus 2 because they're not like terms. I can't add and subtract them. Now when I've done that, what does my line look like? Well, I have plus 5x minus 7x is minus 2x plus 2 is equal to minus 6. Now subtract by 2. I end up with minus 2x is equal to minus 8. And now I want to end up with 1x. Well, I know if I divide any number by itself, I end up with 1. This will be important throughout lots of maths. Any number divided by itself is 1. So to get 1x, I divide by the coefficient in front of the x. I end up with 1x, which we usually write as just x, is equal to minus divided by minus is plus, 8 divided by 2 is 4. Let's do another one of the same type, but here I see I have a little bit of simplifying I can do first. I have like terms. So I have minus 6 plus 2, I have 2x, minus 6 plus 2 is minus 4 is equal to minus x plus 5. And now I can start rearranging like I did here. I don't want that x on the right hand side. So plus 1x, I know that there's a secret 1 in front of them. 1x, and when I do that I end up with 3x minus 4 is equal to 5. I have a minus 4 here. I want 0, so I must add 4 to both sides. To get to 0 from minus 4 I would have to add 4. 3x is equal to 9. I want to get 1x, so I have to divide by 3, and I end up with 1x is equal to 3. Next I need to multiply out my brackets. So I know if I have 3 outside of a bracket, it means multiply. So I'm going to multiply 3 by each thing inside the bracket. And here I have a minus, and a minus you can think of as being a minus 1 if you like, but a minus is going to get multiplied by each thing inside the bracket in the same way as a standard looking number would. So 3 by 2x is going to give me 6x, 3 by 5 is going to give me 15, minus multiplied by plus 4x is minus 4x, and minus multiplied by plus 10 is going to be minus 10, minus by plus is going to give me minus. That's equal to 3, and now I see I have a bunch of like terms. I have stuff involving x, and I have pure numbers. So now I've gathered them together by putting different marks underneath them. I have 6x minus 4x is 2x, and 15 minus 10 is going to give me plus 5. And then I need to rearrange. We're effectively back to our first situation. I don't want that plus 5 there. Minus 5 from both sides to get to 0 for my pure numbers on the left hand side, and I have 2x is equal to minus 2, and I divide by 2 in order to get 1x. 2 divided by 2 will give me 1. So divide by the coefficient in front of the x, and x is minus divided by plus is minus. 2 divided by 2 we know is 1. Now if we get an English type question, we have to think about the language in it very carefully. The sum of two consecutive natural numbers is 27. What are the numbers? Well, we need to take this question and we need to label. So what does sum mean? Well, sum means we added stuff together. Consecutive. What does consecutive mean? It means one number after the other. One after the other. Or the next number. And natural numbers we know would be numbers like 1, 2, 3, 4, continuing on up. And we know what the number 27 means. So I now know that I'm adding up numbers, and I know that I'm dealing with one number after the other. So the next number, and I know that my answers have to be natural numbers. So we need to think carefully about our consecutive number. If I had, say, the number 6, what would be the next consecutive number if I was just on a number line, if I was just going up through the natural numbers? The next consecutive number would be 7. It's the next number in that type of list. But if I was dealing with even numbers, so let's say natural numbers here, if I was dealing with even numbers, I'd need to be careful. So if I started off with the even number 12, what would be the next even number? Or what would be next consecutive even number? Next consecutive even number would be 14. So consecutive just means the next number in a particular context. Now that we have that, if we know that we start off with a particular number, let's not do a solid line there. If we start off with a particular number, well, let's just call it x. What would be the next consecutive number if we're dealing with our natural numbers? Well, it would be x plus 1. Because with our natural numbers, if we started off at x, 6, and then 6 plus 1 is 7. So x plus 1. This is 6 plus 1, x plus 1. So now I know my two numbers. And this is a very important thing to be able to get for more Englishy type questions, which is where the exams really are going. So we need to be able to interpret this type of language. So if I add up two consecutive numbers, I get 27. So x plus the next consecutive number, I'll put it in brackets if I like, it's 27. So I can multiply this out, I suppose. So plus multiplied by stuff in here. I have x plus 1 is equal to 27. And I have x plus x is going to give me 2x plus 1 is equal to 27. I want to get rid of that 1. 2x is equal to 26. So I need to divide both sides by 2, and I get 13. But my job's not done because I was asked for what are the numbers. So 13 is my first number, and then the next consecutive number, my x plus 1, would be 14 for the natural numbers. Now this is where we really need to be leading ourselves, that we can not only handle our basic application type questions, but that we can interpret the language and problem solve, figure out the steps in a problem. We have to tell ourselves a story here, and at higher level, that's where we're pushing ourselves towards. And that is what we need for now.